All right, so today we are continuing with our sketching of the graph. So again, we're going to be finding a whole bunch of different parts to kind of give us a rough picture of the graph of a polynomial. We want to refine that as much as possible to be accurate without actually using, a graphing calculator or some utility that allows us to graph it. So yesterday we talked about factoring. Okay, so we factored a polynomial to find the zeros, and in that factoring we found about something new. I'm not sure if you guys went over this last year, but something called multiplicity. So multiplicity is when we have a factor that gives us the same solution more than once. Okay, so again, here we had x squared equals 0. So x equals 0 is a solution, but we say that this solution has a multiplicity of 2. Okay, and what multiplicity does is it helps us, again, refine our zeros. So normally, when we talk about zeros, right, they cross the x-axis. Right, there's a lot of different names. 0. So I forgot how to spell. I was on the right path. Solution, right? We came up also with a factor or x-intercept, right? So we have two rules when we're talking about multiplicity. So if x minus a to the k. Okay, so we're looking at, again, x minus a to some power k. Okay, so k is going to change depending on what we're looking at. It could be squared. It could be to the 5th. Who knows? So our first instance, if k is an odd number, okay, which also includes 1, right? No, that's not what I want to say. Okay, so if k is an odd exponent, then the graph of the polynomial will pass through the x-axis, okay, like we see here. Right, so if you had something like x minus 1 to the 5th, all right, whatever your graph looks like outside, when we pass through 1, it goes through the graph. Okay, so it goes through the x-axis. So if we're above it, it'll go below. If you're below it, it'll go above. Our second case is if k is even, then what happens? How do I want to say this? If k is an even power, then the graph will touch but will not pass through the x-axis. Okay, so there the x-axis kind of acts like a force field. All right, so say if you had x minus 1 squared, at x equals 1, right, you'll come down, you'll touch it at 1 because it's a solution, but then it'll stay above the x-axis, okay? Let me move that down for you a little bit. All right. So today what we're actually going to do is we'll start to sketch a graph. Let me see if I have any extra. There we go. All right, so give me 1 second. All right, so we have, is everybody good with this? I'm going to flip the page. Okay. So we have 4 resources or 4 things that we can focus on in order to sketch the graph. First, we have the end behavior, right? So we talked about that. It depends if it's, even or odd degree. And then it also depends on our leading coefficient. We have our zeros and our factors, right? So when we find our zeros, they're specific points that we can plot. Okay. With this, I'm going to put. Also, we can always use the y-intercept. The y-intercept is the easiest to find. All we have to do is plug in x equals 0. All right. So in general, we have our intercepts, right? X-intercepts, which are zeros and factors, and you have your y-intercepts. Then we can also use, wow, I can't count. That's not number 4. That's number 3. We have the number of turns, right? So we talked about this briefly, and I'll go into it more today. If I have something to the 5th power, then I'm going to have 4 turns, right? So right, we found that by taking the degree and subtracting 1 from it. All right, and then combined with the zeros and factors, I should have put those together, we have multiplicity, which tells us, are we going crossing the x-axis or are we bouncing off of it, if you want to say. All right, so let's take a look at actually sketching a graph. Let me get a good... All right. I don't want to do that one. So we're going to sketch the graph of 3x to the 4th minus 4x cubed. How is it writing on this? Can you guys see that okay with the graph lines? Or do you want me to go back to the line paper for this?
It's good.
It's good? Okay. All right, so the first thing we're going to do is find the zeros. All right, that's probably the easiest. Now, obviously, you don't have graph paper with you. I mean, you might, but don't worry about, being so precise right now. We're not looking for that. So what I'm doing here is I'm just marking off our units. All right, so I'm going to skip a line, so every other unit is 1. So here we have 1, 2, 3, 4, so on and so forth like that. Okay, so we can find our zeros. All right, so we're going to factor. So here, well, I can't factor a number between 3 and 4, right? For my coefficients, there's no common multiple there, or common factor. But what I can pull out is an x to the third. So I have x to the third. When I pull out an x to the third from here, I'm left with 3x. When I pull out an x to the third over there, I'm left with 4. So I have x. Remember, we set this equal to 0. So I have x to the third equals 0. And I have 3x minus 4 equals 0. So here I get x equals 0 with a multiplicity of 3. All right, so that's telling me I'm going to cross through my graph. Here, I'm going to have a 0 of 4/3. All right, so again, we're just sketching, so it doesn't have to be exactly precise, but just know that 4/3 is 1 1/3, or 1.3. So it's going to be a little above 1. So let's plot our zeros. Okay, so I have 1, 0 here at 0. And then my other one is going to be, well, this is 1.5, so it'll be about in the middle of there. Okay, so I have my 2 zeros. Okay, then we're going to look at the end behavior. All right, so there you go back to your original function. It is a positive exponent. I'm sorry, it is an even exponent and a positive coefficient. So we're going up on both sides. Now this part, I would just, just draw an up over here and an up over here. They may not be, directly where we need them to be. Okay, but it gives us a feel of where the graph should be going, right? So if you're sketching the graph and you end up starting to go this way, you go, oh no, I should be ending up going up. Okay, so now this is something that I didn't talk about, but our outside zeros, okay, here we only have 2, so they're both outside. Our outside zeros will follow the end behavior, okay? So from here, I know I'm going to be going up. From here, I know I'm going to be going up. Okay, so we got a good amount of information, right? So I know I'm going up from here. I'm going up from here. What's happening in between? Okay, I know. Okay, so this is a bit of a side note. I know that I'm going to have possibly 3 turns. But my issue here is I only have 2 zeros, right? If I had all 4 zeros, right, I'll just sketch that. If I had 4 zeros, well then yeah, I would have 3 turns. 1, 2, 3. Okay. But because I have this, all right, I don't have much to go off of. So The problem is we're kind of stuck here. Okay, I don't know what's happening in between. I know I have to go underneath because of the multiplicity. Okay, this has to go through because it's one solution. This has to go through because it's a multiplicity of 3. So the last thing you're going to do how do I want to say this? So we're going to pick a few points. We're going to pick a few points to flesh out the graph. Okay. So you could go ahead and you can pick numbers on the outside if you want a more accurate. You can plug in 2. Okay. But like I said, we're just going to focus in between here. So the first one I can pick is a really simple one, x equals 1. Right? I don't know where x equals 1 is going to be. Is it going to be close to here? Is it going to be somewhere down here? So let's plug in 1. Now, again, we're going to go back to our original function. So we're going to find f of 1. So we're going to have 3 times 1 to the 4th minus 4 times 1 to the 3rd. Always pick numbers that are simple for you, okay? If you can't pick 1, try to pick 0. Okay, obviously we know that 0 already works, right? But it's really easy plugging in 0. This, we get f of 1 equals -1. So at 1, I'm here at -1. Okay. I know I have to turn up at some point, right? So let's try to figure out where we turn up. So I'm just going to put it over here just so we don't run out of room. This goes with 0.4. So let's pick maybe 1/2. Okay, so f of 1/2 or 0.5, however you want to put it. All right, so here, if you plug in 1/2, did they do it here? No, I'm just going to do it real quick. So we have 3 times 1/2 to the 4th minus 4 times 1/2 to the 3rd. So there we get negative 0.3125. Okay, so at 1/2, I'm going to be maybe about here. Okay, so what happens here, okay, is I have to come kind of flat, and then I'm going to have to drop and come back up. All right, so this is a very, pun intended, sketchy graph. But, if you're looking for some data, for some information, it gives you a rough idea of what we're going to look at. Okay, any questions? All right. So,